This video covers how to change between polar and Cartesian notation. Polar notation is written in parentheses. The first number is the magnitude of the vector, and the second number is the angle above the positive x-axis. Cartesian notation is also written in parentheses, where the x component is written first and the y component is written second. Let's do an example. Here we have a two-dimensional velocity written in polar notation, and we want to convert it into Cartesian notation. The velocity is a magnitude 20 meters per second directed 40 degrees above the positive x-axis. Now, to convert into Cartesian notation, we will first calculate the velocity in the x direction, and then we will calculate the velocity in the y direction. And to do this, we're going to use trigonometry. And just to review, sine of theta is going to equal opposite over hypotenuse, cosine of theta will equal adjacent over hypotenuse, and tangent of theta is going to equal opposite over adjacent. So let's first calculate the velocity in the x direction. We know that our angle theta, which is now 40, so 40 degrees, cosine of 40 degrees equals the adjacent value v of x over the hypotenuse, which is 20. And we can plug and chug and find that the velocity in the x direction is 15.3 meters per second. Next, we can calculate the velocity in the y direction. We're going to look at our angle 40 again, and we're going to say sine of 40 equals the opposite, v of y, over 20, the hypotenuse. And when we plug and chug, we find that the velocity in the y direction equals 12.9 meters per second. So we went from polar notation, which was 20 meters per second, 40 degrees, to what is now Cartesian notation, which is 15.3 meters per second, 12.9 meters per second. Now let's convert from Cartesian to polar notation. For this problem, we have a force in the negative x direction, which is going to be 9 newtons, and a force in the positive y direction, which is going to be 7 newtons. And we want to find the magnitude of the force and the angle above the x-axis. First, we will use the Pythagorean theorem to find the magnitude. We are looking for this c value, right? So we're going to do 7 squared plus 9 squared. And when we plug and chug, we find that our value c, or the magnitude of this force, is 11.4 newtons. All right, now we want to find the angle. So to do this, we're going to use tangent, and if we simply use the values 7 and 9, we will find that the angle above the negative x-axis. This is okay, but not the final theta value that we are looking for, since we want the angle above the positive x-axis. So instead, we're going to find this angle between the negative x-axis and our magnitude, and we're going to call this angle theta star. So we're going to say theta star is equal to 7 over 9. And if we use our inverse tangent, we find that theta star is equal to 38 degrees. We know that the angle between the positive x and the negative x-axis is 180 degrees. So in order to find our missing theta, we will want to do 180 minus theta star. And when we plug in theta star, we see that this theta value is equal to 142 degrees. So we are given an original Cartesian notation of negative 9 newtons, 7 newtons, and this, in turn, in polar coordinates, or polar notation, is 11.4 newtons, 142 degrees.